Alright, so this one is 4 sine theta plus 3 cos theta. So usually we would use an expansion of a compound angle of sine, so sine theta plus alpha. But in this case they've told us to use cos. So you can actually use any, it's just easier to do it, to line it up nicely. But that's okay, they've told us to use cos, so here we go. So if I expand this, I'm going to use theta instead of x here. If I expand that, I get r cos theta cos alpha minus r sine theta sine alpha. Now if I can compare that to what I have, the cos comes first, so I'm going to put 3 cos theta here, and there's a minus, so, and I've got a 4 sine theta, but it's positive, so I'm going to have to say minus 4 sine theta here. So if I can compare those two things, you can see that my r sine theta is going to be, so here's sine theta, here's sine theta, so r alpha must be the rest, sine alpha must be negative 4, and my r cos alpha, so here's cos theta, so the other part, the r cos alpha, must be 3. Alright, so if you think about it, where is the sine negative and the cos positive? And that would only be in this quadrant here. So in that quadrant, when I do the tan, so when I'm looking at tan alpha, well, I'm looking at the angle I want here, so the alpha angle, it's going to be 360 minus the acute angle. So really my alpha here is going to be, in this case, 360 minus my acute angle, which would be inverse tan of 4 on 3. So if we were just looking normally and saying, oh, I've got to divide, oh, that's minus 4 on 3, if I divide the first by the second. And then you'd go, oh, tan needs to be negative. All right, so that's this quadrant and this quadrant, but that's not enough information. If we go back to here, we've got sine being negative and cos being positive, which is only this quadrant here. So you just got to be a little bit careful in this case. So yeah, if we'd used sine theta plus alpha and expanded that, it would have been easier. Anyway, so again, when I'm even doing this alpha here, it's a little bit incorrect to write this here and here, but because really the angle I want for this expansion is this angle here, which is alpha is 360 minus inverse tan 4 on 3. And what I'm going to also do is just put that in my, store that alpha in my calculator. It equals, just so we know, it's like a 306.87-ish or 76 something. But I'm going to store it in my calculator, so I've got the exact answer in my calculator. So now if I go back, I've got the, oh, don't forget the R. The R's are easy, of course, because I've got a 3, 4, so it's going to be 5. So 3, 4, 5 triangle. So it's going to be 5, and remember how we get that, so square r squared sine squared alpha plus r squared cos squared alpha equals, and add them together. So you're just getting sine squared plus cos squared is 1. Hopefully that's okay. I won't go into that. So here I'm getting, now I've changed from 4 sine theta, can't even see it anymore, 4 sine theta plus 3 cos theta. I can't solve anything like that, so I'm putting it all in one. 5 cos theta plus alpha, where alpha is this over here. And now I can solve, because it says hence solve, so I've jumped right to this part, this equation. So if we have a look, there's also a little tricky part here. This is easy, 2.5, so we're looking for a half. Now, that would be easy usually, but remember, just give myself a bit of room here, got our alpha there. Remember that theta, we're saying here, is between 0 and 360, but we're solving right now at this stage here for theta plus alpha. Now remember, alpha over here is 306. So really I need to add 306 to each of the 0 plus 306 something. So let's just put alpha. So it's going to be between whatever I better put it, 306 something. This is theta plus alpha, and 306 plus, so it's 360 plus 306 something. I can't see that. So they're the quadrants I'm going to look in. So if you think about it, it's almost 306. It's almost 360. It's almost like I'm doubling up whatever I would get for the original theta. Or sorry, doubling up. I'm adding 360 to it. I'm really adding 306 to it. So what I can do is, instead of thinking, oh, what quadrant I'm in, let's just go back to this for a second. So if I were to solve for theta plus alpha, if I was looking at a half and I'm going all the way around, so this is positive, so I'm looking here and here, all stations 2 central, so A and C, I would get 60 degrees in this one and 360 minus 60, so 300 in this quadrant. But if I add 306 to my limits, I'm almost going really round twice. So I'm going to take a bit of bet here and just add 360, so to each of these. So that would be 360 plus 60 is 420 is what I'm looking at. Oops, 420 even. And then 300 plus 360, so I'm looking at 660 here. So let's see if I end up within the right quadrants, which I think I will. So if I minus alpha now from those two, remember alpha is over here and I've stored it so I can do it really easily. So what I did get, but again, check my answers, please. Check that you get the same. I get these, so I do know I'm going to get 2. If I have a look, are those angles between the original now, 0 to 360? Yes, they are. So I feel like I'm safe there. Hope that helps.